Yeah.
Okay, yeah, nice. Kill the music, my dear. And we nearly got our timings right that time, Nish.
I know.
Yeah, we're doing really well. Good morning, or good afternoon. Actually, it's good morning for one more minute, Bucky. Good morning to you.
Good morning. Good morning, Leon.
How are you? Are you well?
Yeah, I'm more alert, as you can see.
Yeah, that was humorous. For everyone watching, Bucky's a fantastic science teacher who's kindly agreed to join us. And when we called this morning to do a test, let's just say it wasn't the ideal time to call. Yeah, brilliant, Bucky. Thank you so much for joining us. It's a real pleasure to have you on and getting to teach specifically chemistry, because even when we from the feedback we've had so far, we know that people wanted things to be less general than just saying science, and now we're offering, I think it's going to be 5 different lessons of science throughout the week, and we're going to have 2 chemistry lessons with yourself, and then alternating biology and alternating chemistry with Mr. Michael Scott. So going to be a range of great things. So I'm going to ask you and invite you to introduce yourself, Bucky, and then when you share your screen, and just tell us when you want us to move between both screens for you.
All right. Okay. Thank you. All right. So my name is Bucky Yusuf, and I'm going to be taking the chemistry session today. And we're going to start off by actually looking at states of matter. So
yeah, in the bottom right hand corner, it will just say present now, and it will ask you which part of your screen you'd like to present.
Okay.
And obviously, for all the teachers who are tuned in watching as well, it's really just good to know that people are trying different things, doing it in different ways. And I'm going to be posting some highlights of people using visualizers, people using their phone to teach, etc. And obviously, we're using Google as part of what we're offering as well. And so, Bucky, are you more a Google or a Microsoft fan, Bucky? Is that a fair question?
Microsoft, but I liking my use of Google as well.
Google, yeah. Obviously, if Google were giving people a chance to do free advertising space on their bodies, I'd probably volunteer for that, I think. But I just grew up with Google. I didn't grow up with Microsoft, so I'm sure it's just.
Oh, okay, that's interesting. Okay.
Yeah, I'm sure it's just as good if you take out all the quality and standards. So shall I move across to your screen?
Yes, hopefully you can actually see my screen now clearly.
Just going over to it now, and brilliant. Yes, states of matter.
All right, thank you. So if you'd like to show me as well, so I can actually just talk through. So this session is just an easy reintroduction to chemistry, and will allow us to review what we should have done in Key Stage 3. And if we haven't, we've just started with GCSEs, just to reintroduce ourselves to the 3 states of matter. And we can look at the do now question, where it asks just 2 very simple things. Give examples of elements at room temperature that are solid, liquid, and gas. And then think about how the particles are arranged in these three states of matter. So a lot of students will find it easy to name examples of solids, like there are metals. 75% of the periodic table is actually made up of metals. So you'd have things like lithium, sodium, beryllium, etc. You can even think quite easily of gases, so like nitrogen and oxygen, but there are actually only a few examples of elements that are liquid. The one on the left-hand side, lovely colour, I have to say, is an example of bromine, which is a group 7 element. And on the right-hand side is the only example of a metal that exists at room temperature as a liquid, which is mercury. Now, moving on, I want to actually just take things up a little step. So we've got core, extension, and challenge. So hopefully you've got a sheet of paper in front of you or even an exercise book. And I'd like you to think about how you would draw 3 boxes to represent the particles as they're normally drawn in a solid, liquid, and gas. Now, for the extension, think about the words that you might use to describe the particles in a solid, liquid, or gas. And so, for example, can you squash them? You might think about density. How heavy are they? Which was heavier, the solid, liquid, or gas? And if you want to actually go up to the challenge, you can think about describing exactly how the particles are arranged and the forces of attraction between them. You'll note in the bottom right-hand corner that it's 11 marks. And when we go through how you should ideally represent your answers, I'm going to break it down so you can actually see what would earn you a point for each of those 11 marks. Okay, so normally I will give you a few minutes, and hopefully when you review this particular PowerPoint or video, you can actually spend a little bit more time. But I want to talk through some of the key things that you need to make sure that you've got in your diagrams and in your explanations for the 3 states of matter. So let's start with solid first. Now, in a solid, you need to make sure that you've got a regular pattern. As you can see here with my mouse, you've got all of the particles, they're represented as circles, and they're all touching each other. So it's a regular pattern, that's how we describe it. Now underneath, you've got a breakdown of the marks. As I said before, you get a mark for showing circles for the particles, to represent the particles, a mark to show that the particles are all the same size and that they're touching, and that they're in ordered rows. Now, if we look at how the particles are arranged in a liquid, when you compare it to the solid, you'll notice they're not quite in neat rows. There are spaces between them, and some of the particles don't even touch. Okay, so the same thing again as the first one for the solid. You've got particles there. The circles represent particles. Again, the particles are all the same size. Most of them are touching, but you may see that there are gaps between some of them, and that is acceptable. And more importantly, they're in a random order. Now, when we look at the particle arrangements in a gas, there's only 3 here, and that is just to show that there are wide spaces between them, okay? So ideally, in your box, you should have less than, it says less than 10, I'd even say less than 5, just to show that there are very few particles there. Again, they're all the same size, and there's lots of space between the particles, which shows that they are not touching. Now, this is a model answer that would get you about 11 marks. Now, on to one part I didn't represent in the answer, forces of attraction between the particles. And what we're going to do is consider what the forces of attraction are like in a solid, liquid, and gas, and how they are slightly different to each other. And you've got these pictures on the left-hand side just to represent what we're talking about. So in the forces of attraction in solids, I've highlighted yellow the key aspects. The attraction between the particles is strong, and that is the reason why you have a regular pattern of particles in rows, okay? So they are moving and vibrating the spot. So imagine that you're a particle and it's a cold day and you're shivering on the spot. You may not be moving around, but you're shivering on the spot. So we call that the vibrating, okay? So even though it's not always clear to see, the solid particles always vibrate. If we look at the forces of attraction in liquids, again, I've highlighted the key parts in yellow. They're not as strong as in solids. However, they are strong enough to keep the particles from moving away. And lastly, with the gases, the forces of attraction are so weak, this is the reason why it causes the gas particles to move around in every direction. And here, even though it may not be quite clear to see, this represents a cork. It shows that if you've got a container, the gas particles will actually fill it up completely. Okay, so believe it or not, that is enough information to help us go through and demonstrate our learning with two different questions. I'll just quickly point out that you've got the question with the red box around it, which is really easy. And that just recaps what we've looked at the first few minutes of this session. If you are comfortable with this and you want to challenge your thinking, here is in a blue box is a more challenging or higher tier question. Okay, so you're just talking in the red one about describing the arrangement of the particles. And in the blue box, they actually give you the diagram for the three states of matter, and they want you to evaluate the accuracy of this model. Each of the questions are worth 6 marks. And as you think about your answers to this, I want you to think about 3 things, just to keep this simple. What are the relevant keywords that you need to include in your answers? Think about the key points, the key sentences that will get you each mark, and make sure that whatever you write is clearly explained, that anyone else can actually read it, can understand what you're trying to say, and can award you the mark. Okay, so let's unpick this a little bit just to see what will actually earn you the marks for these 2 questions. So it says to describe the arrangement and the movement of particles in the 3 states of matter. And it takes it a little bit more beyond what we've actually covered to think about what happens in the particles in liquid during boiling. So I'm going to just uncover the 6 aspects. So as we showed at the start of the PowerPoint presentation, you should make sure that your particles are the same size in a solid and they're drawn closely together and they are regularly arranged. And you need to explain about the fact that they vibrate in their position. So they don't move per se, but they vibrate. The particles in a liquid are close together and randomly arranged, and they can easily move around each other, which is the reason why some of them may have more gaps between them than you would in a solid. Particles in a gas are far apart and randomly arranged, and they can move around. And when you have boiling, heat energy is actually transferred to the particles. Now, with the last part, this was a screen grab from a website that I used. And this is just to remind you about the fact that always check through the answers that you wrote down, and always check the information on the website. It says about the bond, actually, the correct explanation should be the forces of attraction between the particles are overcome. Now, when we go to the next question, which is a lot more demanding, before we go to the answer, it says about evaluating the accuracy of this model. And some of you may not even be aware of what that word means. So I'm just going to just break it down. If you ever see the word evaluate in an exam question, what it's asking you to think about is what is good about whatever you're being presented with and what is an issue. So if we were to rephrase this, they've given you the diagram for the 3 states of matter, and they're asking you to say what is good about this model of accurate, about how they've depicted this model, and what is an issue, what's not necessarily shown in this particular model. So with that in mind, we'll uncover the good points of the strength, and you need to make sure that the following are included in your answers. As we said before at the start of the lesson, you've got the particles in a solid and liquid, which are close together, and they're far apart in a gas, which is a true representation. In a solid, they are regularly arranged. In a liquid, less so, and in a gas, more randomly arranged. So that is an accurate way we could actually show the particles in a solid, liquid, and gas. The weaknesses are as followed. However, they are 2D or 2-dimensional representation. They're not 3D, so they're not actually showing them as is. Now, here, I don't know how many of you remember I said that generally you need to have only a few particles in gases that are shown. You've got 5, and it shows that some of them are quite close to each other, which isn't quite accurate. You can't see any static movement. So in some diagrams, you'll actually see a little, like little curves around here to show that the particles are actually moving. And lastly, it doesn't actually tell you anything about the energy that's within each of these three things here. Okay, so believe it or not, we've actually come towards the end of this session. And I'd like you to think about the limitations of the particle model. So, is there anything else within this particle model that's not being represented or shown? Some of you, this will be the first time you're actually covering it, that's not an issue. So I've actually given you a screen grab of a very straightforward video explanation by Helen Rogerson. I've chosen this because it's only for about 2 minutes long. So if you're like me and you get bored of blogs very easily, this will summarize the key points in a short amount of time. And you can also take some notes down as well. So that's the end of today's session. With the next chemistry session, what we're going to do is have a few review questions about what we've looked at today, and then extend the idea of the states of matter and the particle model into showing what actually happens when we have changes of state. Thank you very much.
Thank you so much, Bucky. That's really, really appreciated. Yeah, great. You've been doing quite a few presentations online thus far during the lockdown, haven't you?
I have, yes. This is my very first one for actual lessons beyond my own school. So in my school, this is going to be the third week actually in which we're actually doing distance learning, and we've been using Google Classroom just to upload presentations like this sometimes, or maybe go through worksheets, exam questions, or even have video conference lessons as well. So yeah, it's quite interesting. I do enjoy actually operating and interacting with people this way, but after sometimes it does get a little bit too much because you may have about like half a dozen different sessions in a day, which is a lot to deal with.
It reminds me actually how we used to do like an hour lesson 5 or 6 times in a day, back to back to back. When you've got a full day in teaching, you forget how draining it is, because I know even some of the teachers doing 2 lessons, or like you say, 2 or 3 lessons online, 20-minute, half-hour lessons, and you're just like, wow, it takes so much focus.
Absolutely, but it's great fun though. At least I'm enjoying it though, because it allows me to connect with my students and allows us to still connect to the schools, and the learning can still continue as well.
Yeah, that's the most important thing. And also we forget how much energy we take from the students. Do you know what I mean? Their excitement, their passion, or even sometimes, what you'd call cheekiness or naughtiness is it just kind of adds to it all adds to the energy, doesn't it?
Yeah, I don't mind the cheeky or the naughty ones, and there's usually a reason for it. Sometimes it's just a little bit of, a little bit of fun. But when it comes down to focusing for lessons, then I do take it seriously. But it's, as you say, it just adds to the flavour of what we experience within the classroom.
Yeah. Energizing. Let's call it energizing. The cheekiness and energizing. Right. Well, thank you so much. Really looking forward to having you later on in the week as well. And
okay, thank you.
Yeah, I'll pass over to Nish to send us out.
All right, thank you. So the optional task for science today, chemistry, is describe the particle arrangements in the 3 states of matter. And there is a second one, link and explain the forces of attraction in the 3 states of matter and boiling point. So if you missed anything, all our sessions are on Facebook and YouTube, and all the links and comments, all the links and resources are on there as well. That is all of our lessons for today, but we'll be back tomorrow. There is also another website where you can catch up on everything if you missed anything before, and all the links to everything are on here too. There is a code, but it's very easy, me123, and then you'll be able to access everything that we've done so far.
Brilliant. Thank you so much, Nisa. Thanks again for all your help, and thanks to all the teachers who have kindly offered to assist us, and to those who are volunteering. Look forward to getting more people up and live online, and very much look forward to being back with you all again tomorrow.
Yes.